as Matt said, I'm going to talk about Apple's new low latency spec, why I'm thrilled in some ways, not quite as much in some other ways, and we'll sort of get into some of the details of what Apple's announced, what it enables, how it's different to some of the other approaches, and where some of the pain points are, at least from what I've seen. This is all pretty fresh. WWDC was only a couple of weeks ago, and Matt kind of pinged me last week and went, "Hey, can you do a talk on this?" I'm like, "Sure, let me learn about it, but why not?" Cool. So, I guess to set a background, so I work at CBS Interactive. We do a lot of live streaming. One of the events we did recently in February was, something you might have heard of, Super Bowl, breaking records of streaming, of concurrence, of basically everything, biggest event on the internet sort of things. So I want to set a bit of a background for sort of where we at CBS really are today with latency, and as we start to talk about low latency, also start to talk about some of the trade-offs that are involved in really being able to support lower latency while still getting to that good user experience. So for a lot of our streams today, we're still doing 6-second segments, 2-second GOPs, 2-second keyframe intervals. We've got some businesses starting to test with 2-second segments. A lot of our players today for live streams will still start 3 segments behind the live edge, so really that means that we've probably got a minimum latency there of about 18 seconds. In reality, for a lot of our streams, that means that we're probably at 25 to 30 plus seconds, but we have proven this out at scale of millions of concurrent viewers. So this is really sort of where we are today, what we're happy with using on really big scale events. The other thing that I'll mention is that there can be multiple other sources of latency beyond just the segment and how far back from the live edge you're running. With a lot of traditional live streaming technologies, you'll have players polling manifests at certain intervals. Often that's like half your segment duration. So if you've got 6-second segments, you might have polling happening every 3 seconds. It could mean that you could end up missing an update to a manifest and then having to wait for that segment to appear in a later fetch of a manifest. And then really the other side for us being a broadcaster is that we may not always be picking up a source at the optimal location. So in some of our workflows, the source that we pick up may have already gone through multiple satellite uplink and downlinks from stadium to broadcast centers out to local affiliate stations. So that can add pretty significant amounts of delay to the workflow already. We may also have cases where as part of some of those distribution workflows, we've also gone through multiple generational encodes, both as part of that broadcast distribution chain, or even as part of our sort of digital distribution chain, as we may do contribution on site and do some of the adaptive bitrate encoding in the cloud. So there are solutions that we're sort of working on, but I guess what I sort of want to cover in this is that outside of just your sort of end-to-end latency on the OTT distribution side, there's always other sources of latency that we're also dealing with. So when we start to talk about stream latency and live stream latency, there's a number of sort of elements that we have to consider as trade-offs between how low we can get our latency and really the goals of still maintaining that excellent user experience. For us, that's looking at the player buffer, how much time of video content can the players actually keep in buffer. So if we end up with problems with the networking conditions or other elements of the video workflow, there's more time to be able to recover if you have 18 seconds of buffer than if I have 2 seconds of buffer. Part of this can also impact the quality level that we're able to play at for a particular user. If you're on lower bandwidth connections, we may not be able to go and have the time to download higher renditions ahead of when you need it, so we may only be able to provide you with a lower quality stream as we start to lower the end-to-end latency of that stream. Then, as part of all of that, there's then a risk of rebuffering, which, depending on your type of event and type of stream, could be a big issue. For us on some of the large events like Super Bowl, we may have a captive audience, and people may not, may still just sit through that and wait for the stream to start again. If it's less valuable content, then you may have a large risk of users abandoning content if you provide that get into rebuffer situations. Stream startup time, again, could be an issue depending on sort of your particular scenario. And then, what I also want to cover here is not all content necessarily needs to be delivered with much lower latency. We have events, sports events that are simulcast, across broadcast and all of these OTT digital platforms. But then we now increasingly have more live linear stations where it's content that isn't being broadcast anywhere else. A lot of it is content that's just being played out from clips. It's not always breaking news. So there are use cases where you don't necessarily need latency. So I think low latency. So these are all sort of things that we're considering as we're looking at dropping the latency, and we are seeing a lot of requirements for that as well. With people don't want that experience of watching a game to be ruined. If you're watching the Super Bowl and your neighbor has it on TV and they're 20 seconds ahead and they've seen the touchdown before you see it, that can start to ruin the experience. So we're definitely interested in lowering latency where we can, while at the same time also making sure that we can still achieve a quality of experience of these streams that we're going to be happy with and that our users are going to be happy with. So Apple's low latency spec was not the first. There were implementations from Periscope, and they gave a talk here on their approach. Twitch have implementations of low latency. There's been a number of companies that have low latency HLS or dash-based streaming in production today. There's also a spec that the HLS group and has been working on in trying to get the community talking about an approach that's very different to what Apple have presented. A lot of these existing approaches have been based around using HTTP 1.1 chunk transfer coding for segments, so being able to deliver partial segments to clients and have the clients keep the connection open and just wait for all of the data for a segment to come down. One of the sort of big criticisms and problems with some of these approaches, and so one of my feelings of why Apple have sort of gone the direction they have with their spec is the concerns about really doing bandwidth estimation in an accurate way when using chunk transfer coding. So with that, I'll sort of get into some of the details of what Apple have presented here. But just before we get into that, I want to just put out the disclaimer that this is new. I think as an industry where we're all still learning and evaluating what Apple have put out there. We're all still testing all of these technologies and really trying to determine what's going to be best to provide this low latency experience in a robust way to our user bases. And really overall, scaling live streaming is hard. In general, even without low latency, as you get to larger scale, as you get to more users, while you really target maintaining that great QoE, it's really a problem that we haven't completely solved. Even for us on events like Super Bowl, there was still users that were getting rebuffering, that weren't always having the best experience. So we're still not, as an industry, quite at the point yet where we can provide, broadcast sort of level of robustness of live streaming quality. And on top of that, for us, we're in a world now where the number of devices and platforms that we have to support and get to in the OTT space just seems like it's increasing every day. So with that, there's a number of references, and this was really a lot of what sort of I used in learning about this and putting together this talk. There's a talk that Roger Pantos from Apple did at WWDC introducing this new spec. There's a link in there to the spec document, and then there's been some great documents from both Phils, Phil Harrison at AWS and Phil Clough at Mux. There's not just multiple Matts. There's multiple Phils here too. So yeah, these will be in the slides. I'll make sure we get these shared out after the talk as well. So some of the considerations that Apple presented for their low latency spec is that HTTP is still the standard for online video delivery. And really that to be able to use HTTP to deliver lower latency, we need to get to a point where we make the segments of video, rather than being 6-second segments, we need to go down to smaller segments, maybe 250 milliseconds. On top of that, CDNs are really essential for how we today scale video delivery to end users, how we use CDNs to really cache content. They're good at that, and we need that to be able to effectively deliver live streams to a global audience. On top of that, as we reduce latency, our runway to react gets shorter and shorter. We need to be able to potentially switch renditions if we're getting close to running out of buffer in 600 milliseconds instead of waiting 10 or 20 seconds to switch, because by that point you've run out of buffer and you've got the user in a bad situation. So these were some of the points that Apple presented as sort of their design goals and considerations for their low latency spec. So the first big change to the HLS spec here is adding what Apple are calling the Origin API. So previously, HLS was pretty simple. You could deliver it with a static HTTP server with pass-through storage, and overall didn't really need that much in terms of intelligence from your origin. With the spec that Apple have announced, this all changes quite a lot, and your origin now really has to do a lot more and become a lot more complicated and really track a lot more state. So to advertise that your stream and your server supports this Origin API, you need to include the new Xtx server control tag, and there's a number of features that you can advertise if you do or don't support on your server as part of this. The critical tag is the can block reload, which you have to have set to yes to indicate that you support a number of the features that are mandatory under the spec. And one of the big changes here is now there's underscore HLS prefix query parameters that are now reserved under this Origin API spec. So there's a number already now in the spec that's been proposed, and there could be additional that are added. So make sure you don't use any of those query parameters anymore. Another part of that is Apple have also recommended that those query parameters always be sorted by the client so that all your clients provide them in a consistent order, so that you don't get some clients trying to get to the same manifest on the Origin API, but with a different set of query parameters and hit different cache on CDNs and cause more requests to the origin. Yeah, so now with all of this, traditionally today on our CDNs, we've been ignoring a lot of the time query parameters. Obviously, we can't do this anymore. We need to be able to pass all of these back down to our clients, to our origins, to be able to make sure that we can request all the elements of different playlists that clients may now need. So there's 5 key components here of the Apple low latency HLS spec. The first part's delivering partial segments. So as I talked about, getting down to 250 millisecond size segments. The next part is reducing the latency of how we get to these segments, reducing the number of round trips. Then we'll talk about support for blocking playlist requests, so clients can now wait. The origins have to wait to have the next version of a manifest available before they deliver it to the client. Then we'll talk about delivering playlist delta updates, so playlists now that are in smaller pieces. And then finally, we'll talk about some approaches that allow faster rendition switches when you have a very limited amount of time to react. So first part of this is partial segments. So as I mentioned, today we're delivering 6-second segments. Those will only get advertised when the segment's been encoded, it's been uploaded, it's been delivered to the origin storage, and it's ready now to be delivered. Then the manifest will be updated. With what Apple are now providing, rather than delivering big 6-second segments, we'll generate these partial segments every 250 or so milliseconds. That number is not officially in the spec, but has been mentioned a lot in the Apple talk and in a number of other blog posts. So there is definitely some flexibility, to determine partial segment sizes that work for your particular application. One of the big things here is that partial segments have to be fully available before they get advertised in the manifest. So this I really see as being around trying to address that problem with chunk transfer coding approaches of delivering partial segments over the network. Apple are basically going, no, we're not going to do that. We're just going to have smaller chunks. They're going to be fully available pieces. But then after all of your smaller partial segments, which Apple are calling parts, are available, you then also need to still be able to provide a complete segment so that that can still be used by older legacy backwards compatible players. Or after 3 target durations, the parts will also be removed from the manifest and you'll only list the full segments there. So to support advertising these parts to the client, Apple have added this new Xtx Part Tag. So there's an example of one there. The primary fields that are included in that tag is the duration of that part, the URI, and then a flag called independent, which represents if there's an IDR frame in that part. It doesn't indicate that it necessarily starts with an IDR, but it indicates that there's an IDR frame somewhere in that part. Sorry? Yeah, so if there is an IDR frame anywhere in that part, independent would be set to yes. So there's a number of challenges with this. As I mentioned, parts can only be advertised when fully available, so you need to have that state to know when your parts are available. The parts remain in the manifest for those 3 target durations. We're still going to be in players looking for iframes to start playback or for switching points, which having the independent tag at least will be able to tell us which part has one, so that may give us some hints as where to look. The full segment we still have to be able to generate and provide after we've sent all these parts. There's a lot of questions as we start to look at how do we implement origins and packages and all of those components of the workflow. Do we end up delivering all these parts as individual pieces to our origin and then upload a whole full segment after? Do we try to come up with approaches that allow us to combine together all the multiple parts and then later serve that out as one part, as one full segment? And that then really also then leads into, are there approaches and ways that we could share CDN cache between the parts and the full segment that we're trying to deliver, or would we end up just caching both in the CDN? There's certainly approaches, been exploring around, could we actually shift some of this on its head and use chunk transfer coding for the transfer from our origin to the edge, and then use and send the full segment over that way. But then use byte ranges to be able to access parts of the file while the full file is still being delivered out to the CDN. This may or may not work. There may be varying amounts of support for doing approaches like this on CDNs. Sort of effectively what that would end up leading to is sort of looking something like this, where you would have your parts advertised, you'd be delivering them as byte range requests. There isn't a way in the Xtx Part Tag to actually indicate the client could make byte range requests, so you would at the CDN need to translate query parameters into byte range requests. There's a lot of complexities that might come in here if we tried to get to a point of sharing CDN cache between parts and segments. And I guess if you have enough traffic on your stream where you've got mixed legacy and low latency clients, maybe you've just got enough traffic where sharing the cache isn't an issue. So that was part 1 of 5. Next part here is reducing latency of delivery of these segments. So here we're, at least from my feeling of all of this, it's really about dealing with the case that there's some networks out there, particularly mobile networks or satellite networks, where you might have some pretty long round trip times. If you're on a great fiber connection at home and there's a CDN pop really close to you, maybe you're 20 milliseconds away. If you're on a high latency mobile or satellite connection, you could be hundreds of milliseconds away. So as we're starting to talk about running players at seconds, low seconds of buffers, these multiple hundreds of milliseconds of round trip time can really start to matter. So the next part of the spec that Apple introduced is when the manifest is requested that includes a part, if the server supports it, and it's part of the spec demanded to support this, the server will use HTTP2 server push to, alongside the manifest, also start pushing the next part to the client. So there's multiple different ways of doing this. One of the most common ways I've seen people do this, particularly if you're using CDNs, is to use the link response header from your origin. So there's an example in there where we use the link header, we specify the path to this part, we set it as preload, so that will cause the CDN or the caching servers to go and preload and prefetch, presend that to the client with server push, and then we're advertising a few things like what the MIME type is and things like that, so that the server knows how to generate that response to the client. There's a lot of challenges in getting into this. CDN support for HTTP2 overall, and particularly for server push, varies. Some CDNs also may only support server HTTP2 at the edge and not at the origin, which may not be a problem with link headers here. We may still be able to support the HTTP server push. One of the big issues here could really be if your manifest server and your origin server that are serving the segments are on different domains. This approach with link headers may not work. It may be more difficult. You may have to dynamically switch backends on CDNs or be able to do redirects or things like that. That may add more latency, at least on the side of the CDN going back to the origin. So there's a lot of complexities here in both the HTTP server push side and how we might integrate with some of these approaches where manifests and segments live elsewhere, which could be in use cases like server-side ad insertion, dynamic packaging services, a lot of those sort of use cases. So the next piece here is blocking playlist requests. So today for live streams with HLS, the client will, as I mentioned earlier, at a certain interval, keep polling the manifest again, fetching a new version, and if there's nothing there, I have nothing to do, I'll wait, and then I'll poll again. Eventually I'll get a new segment URL, and then I'll go and download this. What Apple is saying here, to limit the number of polling requests and again to deal with that sort of problem of round trip times here, the client should now make a request with the media sequence number. So if every time in HLS when the playlist changes, the media sequence number will be increased. So here what Apple is saying is make a request with this HLS_MSN for the media sequence number, saying if I just saw sequence 10, now I want sequence 11. Basically, you'll make a request for that playlist, and the origin now and the CDNs are meant to wait until that playlist can be generated, so the connection will just be held open, and eventually when it's available, that playlist will be delivered. There's then, in addition to that, a _HLS_part query parameter that, in addition to the media sequence number, lets you specify a part. Those parts are zero indexed, and just like with the media sequence numbers, you'll increment those as you need to get to the next part. It also means that you have to do some of those calculations of knowing how many parts there should be based on the target part duration and target segment duration and things like that. Ultimately, I think this is one of the really big parts of the spec that really make it difficult to potentially impossible to just use static pass-through like storage-based origins. Today you could use Nginx server, you could use S3 or solutions like that, or media store or other solutions as your origin for HLS content, because there is no real smarts or intelligence needed to deliver these manifests and deliver the segments. Now, in having to generate very different dynamic manifests and having to wait for these responses, this kind of really changes the game a lot in how origins have to behave and what intelligence they need, and potentially CDNs as well. As part of this, it was also mentioned by Apple that CDN should make sure that they batch requests for the same query parameter to the origin, so that you don't end up hammering the origin with requests for what are ultimately going to be the same playlist delivered back to the client. So, next part. So, playlist delta updates. So today, with live streams, there's a couple of different ways of sort of dealing with this sort of problem, but over time, you'll keep adding these new segments to your playlist. You either may keep all the segments for your stream in some cases, and often people use this approach for DVR. So if you want to allow people to start the stream and go back an hour and watch it from the beginning, you may just include all the segments from the entire stream in your playlist, so these playlists keep getting bigger and bigger and bigger. The other approach is with rolling windows, so I may go, hey, I want to keep 10 segments, or I want to keep a minute worth of content, and over time, as new segments are added, you'll start to remove some of the old ones from your playlist. But now that we're dealing with low latency and we're dealing with potentially now a new playlist having to be delivered to the client every time there's a new part, which could be every 250 milliseconds, that adds up as to the amount of data we have to keep sending to the client. So this can be a particular problem, over mobile networks and things like that again. So Apple's approach to this is you'll start up the stream as normal. Your first playlist request will still give you the entire playlist. If it's a DVR or rolling window or whatever, you'll get a playlist as normal. And then over time, the server will be able to start to add this Xtx skip tag, which will basically tell the player that, hey, you shouldn't forget about everything you've seen before, but we're not going to keep sending you stuff you've already got before. And the Xtx skip tag will indicate how many segments were skipped. And again, there's another origin API flag, the _HLS_skip, to indicate that the server supports this behavior. So, this is an example. I don't know if you can actually read it up there, but this is an example of what this looks like. So this is a manifest that includes that skipped segment. The media sequence number is now adjusted as well based on that, and this means now that we don't have to every time go through and deliver the full manifest. We can deliver partial manifests to the player. It does mean that players need the intelligence to know which pieces they now need to keep track of. Okay, so the final sort of part of what Apple introduced here, and then I'll go through and summarize all of this up. And this is enabling faster rendition switches on players. So as I mentioned, we're at low latency, we're at these low number of seconds of latency glass to glass, and our network conditions now start to suffer. We have a CDN problem, we have a local network problem, something's starting to go wrong, and we don't have as much bandwidth as we did before. So now we have a lot shorter period of time to be able to start to deal with getting to another lower quality rendition before the player's going to get into a rebuffer situation. So the approach that Apple have introduced here is they're going to start to allow you to include these Xtx rendition report tags in your manifest to indicate URLs to segments in other renditions. So this means that without having to, today, if a player is, say, playing your 1080p 3 megabit rendition, you're getting too low on bandwidth, you want to go down to the 720, the player would need to go and fetch the latest version of that 720 manifest before you can go in and start playing back at that rendition. What this allows you to do is advertise that, hey, on these other renditions, here's the URL that you should go and hit, and it also tells you there the media sequence number and the part number from those streams, which can be useful if there were discontinuities there and the streams are slightly out of sync, to have some idea of where those streams may be up to. The spec does mention a last I MSN and last I part, but it does say that currently these are unused. So it's a little unclear at the moment as to sort of how you're meant to sort of know where the next IDR frame is in those other renditions. Is the assumption that all of the renditions are always IDR aligned? What should you do if they aren't? Does that then mean you get into situations where you may have to still pull the full manifest so that you actually know where a switching point is? So there's a number of questions still there around really using these rendition reports in the real world, in real players. So to summarize all of this, there are a lot of moving pieces with this. Origin API really adds a lot of complexity across the stack for the client. It needs to be able to deal with all of these new HLS tags. It needs to be able to generate all of these new query parameters for each part of the workflow and cycle. CDNs need to know how to pass this through, but how to still do a good job of caching and what can be cached for long periods, what can't. That is some benefit though in having query parameters that are unique for different versions of manifests. It does actually mean now that once I do get a version of a manifest, I can rely that I can cache it forever. I don't have the problem today that I have with manifests on live streams where I have to set very short TTLs on the CDN because I know those manifests are going to be refetched regularly. So there are some benefits that provides, but then really implementation on the origin is now really shifting to a world where it is an application there, it is a lot more dynamic, there's a lot more code, there's a lot more state that we need to track to really be able to perform all the functions that we need to deliver these streams. On top of that, I think there's still a lot of unknowns here for how this will really work with SSAI solutions, with dynamic packaging solutions. To some levels, a lot of parts of the HLS spec DRM will still work in the same way. Discontinuities should work in the same way here. But then problems like different domains between manifests and segment servers and things like that may start to get a little complicated. There is also varying levels of support for HTTP 2 and for server push. Overall, I think that in the way Apple are using server push, currently only pushing one part at a time alongside a manifest. This doesn't really hit a lot of the common issues I've seen with server push, which is issues with clients like web browsers. If you're getting pushed 15 different objects and there's not enough prioritization of which objects you need first and when, and you can't cancel these requests easily, I think those sort of problems, probably won't be as common with this approach where it's just pushing out like one segment alongside or one part alongside a manifest. I think the big benefit really here is this massively simplifies the bandwidth estimation problem of chunk transfer coding approaches. We are always now still downloading full 250 millisecond segments, so a lot of the ABR switching logic and that side of things doesn't have to change as much. Obviously, rendition reports do complicate some of that side of things, but the core sort of ABR logic and bandwidth estimation can remain mostly the same. So to get started with this, Apple have launched this in beta in iOS 13. It's currently behind a special entitlement flag, so you can't use this in production apps yet. It's unclear yet, if this will land in the iOS 13 final releases, or at what point this will really be treated as something production ready. This is all still pretty early. There's not really been a lot of signs yet around when Safari is going to get support for it. There is also a sample toolkit that Apple provides with a tool for doing segmentation, generating manifests, and then also a sample PHP script that you can use to start to test this, and then get it on your devices, get it on your servers, and start to play around with some of this. I think overall with all of this, there's really still a lot of questions as to, is this going to be where Apple's going to go? Is this really going to be, will the industry as a whole sort of adopt this and take this on as the way to do low latency HLS? And how is some of this also going to map to concepts in other streaming standards like Dash? So overall, I think there's a lot of open questions, but I'm excited to really see where this goes and how as an industry we start to find ways to solve the problems of low latency live video at scale. Look, my feeling at this point is Apple are probably going to do this whether the industry wants it or not. So I think there's very likely a chance here that we're all going to have to do some version of this. But I'm definitely interested in actually starting to get some implementations of this, figuring out how complex is the packager, how complex is the origin. My feeling so far is the answer is very, and it may just be a non-starter for a lot of people to get this to production, but I think at this point I feel there's a lot of unknowns there. Yeah, so I mean, I sort of only very briefly sort of covered on this with how some of these other sort of approaches work, but really with like the Dash CMAF, with some of the HLS.js low latency spec, a lot of these are really relying on using the chunk transfer coding, so advertising to the player as soon as you can start to deliver any of the segment, or potentially even before, hey, here's the URL, you'll deliver it over this HTTP 1.1 chunk transfer coding, so the client may open the connection to the CDN, there may not be data available at that point. Eventually, as the data is available, you'll get it to the client, which, as I mentioned a few times, sort of makes it very difficult to do that bandwidth estimation piece. I think that's really some of my biggest concerns, and I'm imagining Apple's around some of the existing approaches. But then, I think really it's this origin API, the number of query parameters, the amount of interaction you have to have between the client and this origin API and the CDNs and all of these pieces in the middle, I think are going to be very complicated to implement. Right. Well, but the mechanics of like H2 server push probably don't change that much with H3. The major H3 change is likely to be the quick now as the transport. Although Apple do specifically call out in the prelim spec that quick is not being considered as it may work but it may not sort of thing in the current prelim spec. Well, so this is one of the challenges with HTTP server push is that you as a client don't actually really have any way to cancel the server sending you that part. So you'll be getting it, but you may then have also at the same time, your connection now will be congested, starting to receive that part they thought you wanted, while you've actually now also gone to try to fetch the other part, and you as a player developer aren't going to really have any easy ways to change that. So that's definitely a problem on a congested connection. I guess the hope is that the parts being very small segments would hopefully time out over time. Maybe we need to have more aggressive sort of timeouts and things like that on the server, and so that they close the connection on those pushes early, so that the client does have a chance to go and get the next part. You're going to need to be able to track a lot more state from your packager as well, because you're going to need to know when different parts are complete and things like that. There's a lot more complexity, both at I wouldn't want to be a encoder packager vendor. I wouldn't want to be someone building an origin for this. And then, on the CDN side, you really, you do need more capability to have efficient, mid-tier and origin shielding and protection to be able to, collapse a lot of these requests for the same set of query parameters down to the same request to the origin, and not make those a million times. Otherwise, you're going to break the origin all the time. Well, it isn't so much chunk transfer coding as a way to deliver over the network. The concerns and issues that I have with chunk transfer coding is how on the client, on the player end, we can still do accurate bandwidth estimation when you can't just use the standard approaches when we know how large a segment is and how long it took to estimate the network conditions. It starts to get a lot more complicated to figure out what the actual bandwidth of that network connection is with using chunk transfer coding.
Thanks again.
Yeah, thanks, man.